Now next question we are going to study from December 2015 exam, question 4. Okay, everyone give the heading. December 2015 exam, question 4. Very simple question guys, not that much difficult. A speedboat has an initial velocity. Try to see the scenario. What they are saying in the question, a speedboat has some initial velocity when it is subjected to a constant acceleration. Okay, here throughout the journey, what is the scenario here? Acceleration is constant. Okay, so here acceleration is what? Constant. And whenever acceleration is constant, we can apply equation of motion. Okay, what is the condition for equation of motion guys? Acceleration must be constant. Guys, see, acceleration constant doesn't mean that velocity constant. Okay, acceleration constant means velocity increment rate is a constant, increment or decrement rate. Okay, means velocity change rate is constant. Okay, acceleration constant means. So now a speedboat has an initial velocity, has some initial velocity. When it is subjected to a constant acceleration, it is moving constant acceleration. During acceleration period, okay, during that is when A is constant, during acceleration period, it travels a distance 60 meter in 5 seconds and then further 110 meter in next 5 seconds. Okay, try to see the scenario here. Suppose I'm drawing one schematic drawing. Okay, suppose this is a starting point. We will say point number 1. Okay, 1 to 2. Okay, 1 to 2 distance is how much guys? 1 to 2 distance is how much? 1 to 2 distance is how much guys? 60 meter means for first 5 seconds. For first 5 seconds distance is how much? This distance is how much everyone? For first 5 seconds. Okay, everyone. Try to see the scenario here. So this distance is what? This distance is what? 60 meter. And this 60 meter distance covered in how much time? This distance covered in how much time? 5 second time. Okay. Then 2 to 3. Then in 2 to 3 guys, 2 to 3 distance is how much? This 2 to 3 distance is how much? 110. This 2 to 3 meter distance is how much? 110 meter. And this covered in how much time? Again 5 seconds. Means for first 5 seconds, see. And why here distance is different? Because here initial 5 second velocity is lower as compared to next 5 second. Okay, because in every second here velocity is changing. And why here velocity is changing? Because here we have acceleration. But here velocity change rate is same, constant. Okay. Okay guys, are you getting my point? Everyone try to see the scenario. So 1 to 2, 60 meter, 2 to 3. How much guys? 110 meter. Try to see the point here. Huh? Now what they are asking us here in A part? What they are asking us in A part? What we have to do? Sketch the velocity and time graph. Represent the accelerated motion. Okay, very simple scenario. We will see after the B part. In B's first part, what they are asking? Acceleration of speedboat. Okay, in B's first part, what they are asking? Acceleration of the speedboat. And in B's second part, what they are asking? Initial and final velocity of speedboat. Okay. So try to see the scenario. Very simple discussion. So first of all, what we are going to do? We are going to see A part later. Huh? First of all, we are going to solve B's first part and B's second part, and then we will go for the B's, in A part. Okay. Now in A part, what we have to find out? We have to find out acceleration. Okay. What is our target in A part? We have to find out acceleration. Okay. Now try to see the scenario for motion 1 to 2. Okay. For motion 1 to 2. For motion 1 to 2. Huh? See the drawing here, everyone. For motion 1 to 2. What is the displacement 1 to 2? See, for motion 1 to 2. Before that, we will assume let V1 is the initial velocity. V1 means what? Initial velocity in meter per second. Okay. From motion 1 to 2. What is the displacement? Motion 1 to 2. What is the displacement? 1 to 2. How much displacement guys? 60 meter. How much time? 1 to 2 guys? 5 seconds. Now we know equation of motion. Okay, try to see the scenario. What is equation of motion? S is equal to ut plus half at square. Okay, everyone, don't write anything, don't do anything. Okay, yes is how much, guys, here? Yes is how much? Yes is how much? 60 meter. 60 meter. Initial velocity, we assumed v1. Time is how much? 5 seconds plus half. Acceleration is how much? We don't know. That is what we have to calculate it into 5 square. Okay. So what we say? 60 v1, 5 v1 plus 5 square. 5 square means 25. 25 by 2. How much? 12.5. So 12.5 A. Okay, everyone, try to see the scenario. So 5 v1 plus 12.5 A is equal to what, guys? 60, and we will say it as our equation 1. Okay, this is what our equation 1. Okay, from where we got equation 1? We got equation 1 in terms of v1 and A. Everyone, try to see the scenario. Now the next point is what? For motion 1, 2, 3. Similarly, we can consider for motion 1, 2, 3. Here we consider motion 1, 2, 2. Here we consider what? Motion 1, 2, 2. Now we are going to consider motion 1, 2, 3. What is the displacement for motion 1, 2, 3? What is the displacement for motion 1, 2, 3? Motion 1, 2, 3, guys. Not 2, 2, 3. 170. Displacement is what, guys? 170 meter. How much time here? 1, 2, 3. How much time we need, guys, from 1 to 3? See, 1 to 2, 5 seconds, 2 to 3, 5 seconds. So 1 to 3 is how much time? 10 seconds. Okay, so 1 to 3 is time is what? 10 seconds, everyone. So our equation of motion, S is equal to what, everyone? Ut plus half at square. S is how much, guys? S is how much? 170 meter for this here. Okay. Initial velocity we don't know, we assumed v1. Into time is what? 10 seconds. Half. Acceleration we don't know. T square means 10 square. So 170, everyone, is equal to 10 v1. Okay, I have arranged it properly. 10 square means what? 100. 10 square by 2. How much, guys? 10 square by 2. How much 10 square by 2? But 10 square means 100. 10 square by 2 means what? 50A. So what will be the scenario? 10 v1 plus 50A is equal to what, guys? 170, and we are going to say equation number 2. Now how many? So we have 2 equations. See, guys, now you may say, sir, why you consider 1 to 2 and 1 to 3? Why you are not consider 1 to 2 and then 2 to 3? Guys, suppose if you consider 2 to 3, see, 1 to 2, if you consider 1 to 2, we get equation v1a. But if you consider 2 to 3, what is if you consider 2 to 3? For 2 to 3, initial velocity will be v2. So unknown will be what? Here v2. But if you consider 1 to 3, unknown will be what again? Same as this one. Means v1 and a. V1 and a. If you consider 1 to 3, unknown is what? 1. Means v1. 1 to 3. But if you consider 2 to 3, unknown velocity will become 2 to 3, and we will get an expression in terms of v2 and a. But if you want to solve 2 equations, in 2 equations means simultaneous equations, linear equations, so variable must be same. So here is also v1, here is also v1, here is also a, here is also a, means linear equation in 2 variable. So here is also same v1. V1 means we can consider this as x, this as x, this as a y, this as a y. Okay, guys, are you getting my point? Try to see the scenario here. So why I considered 1 to 3 instead of 2 to 3? If you consider 2 to 3, then unknown will become v2. So then there will be 2 equations and what? 3 unknowns, means v1, v2 and a. But if you consider 1 to 2, v1a, and 1 to 3, again v1a. Okay, means 1 to 2, v1a, 1 to 3, v1a. And if you consider 2 to 3, unknown will be v2 and a. Okay, guys, are you getting my point? So in both the equations, we want the same type of unknown. So here, that's why I consider motion 1 to 3. Now everyone has an advanced calculator. So on solving equation 1 and 2. On solving equation what, guys? 1 and 2. Okay, everyone, try to see the scenario. On solving equation 1 and 2, okay, what we will get on solving equation 1 and 2? So everyone go to those who have 991 EX, for them go to the equation mode, linear equation, number of unknowns 2, and put this one in the same format. This is our X, this is Y, this is X, this is Y. So on solving equation 1 and 2, we will get value of what, guys? We will get value of V1 and we will get value of A. Everyone, V1 is equal to 7 meter per second, and what is the value of A, guys? 2 meter per second. Everyone. So this is what our answer of A part. And B's first part, what they are asking, sorry, this is not A part answer, guys, I was wrong. This is a B's first part, this is a B's first part, guys, everyone. And B's second part, they are asking us initial velocity, and V1 is what our in B's second part, what they are asking? Initial velocity and final velocity. So here we got the V1. So V1 is what our initial velocity, and that is what? 7 meter per second. Okay, guys, anyone have any doubt in this discussion? Please observe the things here, everyone. Everyone, please observe the things. So guys, first of all, write down all these points here carefully. Then, first of all, what I told you. See, what is you are saying, sir? In A part, they are asking a this case. What in the beginning I told you? We are going to take A part after the completion of B part. Okay. For drawing, we need a value of velocity. After getting the value of velocity, then we are going to draw the drawing. And at the end, see, that A part you have to solve on the graph only. Okay. You have to solve on the graph. So no problem. You can draw, means because you have to attach the graph only. So you can draw at the beginning only. Means you can consider it as the beginning. Okay. So, but for the drawing the graph, we need a value of velocities. So that's why we calculated first of all B's first part and B's second part. Final velocity is remaining. We will calculate that one. Okay. We will come to the A part, that is not that much difficult. So first of all, everyone, draw this drawing properly, write down V1, then this point and this point. Okay, everyone, please. Now, what they are asking us here in B's second part? What they are asking us here in B's second part, guys? In B's second part, our target is what? Final velocity. And our final velocity at which point? Third point, V3. Okay, try to see the scenario here. So we know this relation. V is equal to U plus AT. So our final velocity is what? V3. Initial velocity is what? V1. A into time is how much, guys? 10 seconds. Okay, we reach 1, 2, 3, 10 seconds. So V3 will be equal to V1. We calculated 7. A how much calculated, guys? 2 into 10. So what is final velocity V3? 27 meter per second square. Okay, guys, are you getting my point? Try to see the scenario here. And for extra part, we will calculate the velocity after 10 seconds also. Okay, that is the extra part. Velocity after 10 seconds. Okay. This is one answer. This is initial velocity. Everyone, this is what initial velocity. Make it as the initial velocity. And here another answer of the second part is what? Final velocity. Okay. And extra part also we will calculate V2, means after 5 seconds. So V2 will become what, guys? V2 will become what? We will need that V2 value while drawing the graph. V2 is equal to V1 plus AT. V1 is how much? 7. So acceleration 2, time is 5. So what will be the V2, guys? 17 meter per second. Okay, not per second square, guys. Please be careful with velocities unit. So this is V2. This is the extra part, guys. Velocity after 5 seconds. Okay, everyone, please write down this B second part. Now guys, try to see the scenario here. What they are asking us here in the A part, okay? means why we doing A part later, because for doing A part we need values of velocities also. Okay, so try to see the scenario. They are asking us try to draw the velocity time graph. Okay, in A part, very simple. If you have a graph, use graph paper. If you don't have a graph, don't worry, you can draw it on your copy. But in exam, whenever they are asking a graph, okay, use the graph paper, take the graph paper and draw it. Okay, sketch the velocity time graph that represent this accelerated motion. Okay, so we have to draw the velocity time graph. Okay, in A part our answer is velocity time graph. Okay, that is what our answer of A part. Okay, now how to do this velocity time graph, guys? Very simple one, not that much difficult. Okay, so as always guys, time on the x-axis and velocity on the y-axis. Okay, see, so now try to see the scenario here. Always try to represent whenever there is a graph question. Scale is most important. Without scale, don't do anything in the graph question. Scale is always important. So what we will take, guys? We have a time is what? What we have a time? Means 1 to 10 second. Means first 5 second and next. So we will take on x-axis. Okay. On x-axis what we will take? 1 centimeter is equal to what? 1 second. 1 centimeter is equal to 1 second. Take a proper pencil scale, guys. If you don't have graph paper, don't worry. Take a proper pencil scale and try to do. 1 centimeter is equal to 1 second. And on y-axis, what we will take? On y-axis, 2 centimeter or 1 centimeter is equal to 5 meter per second. Okay, guys, take this scale. Okay, so first, second, like that. Okay, everyone try to see the scenario. So 5. Okay, 10 second. Okay, everyone, are you getting my point? Then 1 centimeter is equal to 5 meter per second. So take a proper scale. 5, 10, 15, 20, 25 and 30 meter per second. Velocity is in meter per second. Time is in what? Second. Write down these units also beside this one. Okay, this is what a time. Use proper pencil scale, everyone. Don't draw by rough hand. Use proper scale. Measure the each and every distance. Whatever the scale, doesn't necessary how to use my scale only. You can use your own scale. Okay. Now, guys, our initial time is what? 0th second. At 0th second, what is our initial velocity? At 0th second, what is our velocity? 7 meter per second. So we will get a value 7 meters per second. It will come approximately here. So 7 meter per second. After 5 second. After 5 second means our V2. V2 will be what, guys? 17. Okay. So we will have a 17 will be here approximately. And 5. If you have a graph, no need to draw this line. Okay. Because in the graph you can show. So this point. Okay. And always show this point like this. Guys, dot. And beside that. Okay. And then a 10 second. 27. Everyone try to see the scenario here. Okay, I will rub the scale this one. Everyone try to see the scenario here. So this is what our third point. Okay. And guys, if you observe this one, it is a straight line. It must be straight line, everyone. This must be what? A straight line. Okay. Because whenever velocity acceleration is constant, then velocity will increase linearly. Guys, okay. And here I am write down the scale at the top. Okay. You should write down your scale at the top of the graph. Okay. On x-axis, guys, what is our scale? 1 centimeter is equal to what we have considered? 1 second. And on y-axis, what is our scale? 1 centimeter is equal to what we consider? 5 meter per second. Okay, guys? Everyone, write down properly. If you have any doubt, ask me. Please, this line must be in proper scale. Please, everyone. Okay, if you have a graph, use the graph paper. It is the best one. If you don't have a graph, use proper pencil scale. Okay, take the proper measurements and then do the things. Okay, everyone, please.